Okay, chapter 2-5, worksheet 3. This is all about imaginary roots. So if you are given that a plus bi is a root, then you automatically know two roots. Why? Because a plus bi is a root, then it automatically means that a minus bi is a root, and vice versa. Do you all understand what I just said? So if a plus bi is a root, then a minus bi is a root, and vice versa. Now, this is directly off of tonight's worksheet. I'm doing homework problems with you as your actual notes. You're welcome. Okay, you ready? Find a polynomial function with real coefficients that has the given roots. Find a polynomial function that has the given zeros. Yes, it is on your homework. I would put it in your notes just so that you don't screw it up, though. The roots that I give you are 4, 3i, and negative 3i. Now, that means that x is equal to 4 to 3i and to negative 3i. Do we all see that, yes or no? So that means x minus 4 is equal to 0. And then what we're going to do here is we're going to write this as x is equal to plus or minus 3i. Yes or no? Okay? Now, I want to deal with the black one over here, so how do I get rid of that plus or minus? Well, the way we got plus or minus is we took the square root, right? That's how you ended up with the plus or minus. So how do I get rid of the plus or minus? Square it. So we're going to square both sides. So that's going to give me x squared is equal to, what's 3i times 3i? 9i squared. What's I squared equal? Negative 1. So what I have here is x squared is equal to negative 9. Which means now I have x squared plus 9 is equal to 0. Now since I have both of those binomials that equal to 0, what can I do? I can vary them by putting them together by multiplication. So now I'm going to have x minus 4 times x squared plus 9. And now what do I need to do? FOIL. So that's going to give you x cubed plus 9x minus 4x squared minus 36. Now, whenever I do this, I always like my powers in descending order, so I'm going to rewrite this as x cubed minus 4x squared plus 9x minus 36. That is a polynomial with the roots 4, 3i, and negative 3i. Do we all understand that? Can I move on? Same exact concept. Same exact concept, except for this time I'm going to have x is equal to negative 1. X is equal to 6 plus 5i, and x is equal to 6 minus 5i. Yes? What's that? I didn't figure out what to do. Okay, so now what do? I bring the 6 over, right? So I have x minus 6 is equal to 5i, and x minus 6 is equal to negative 5i. Well, how can I rewrite that? So these two can become x minus 6 is equal to plus or minus 5i, right? How do I get rid of that plus or minus? Square both sides. So that gives me x minus 6 times x minus 6 2 times is equal to 25i squared. So I'm going to FOIL this. X squared minus 12x plus 36 is equal to negative 25. Why is that equal to negative 25? Because I squared is equal to negative 1. Why is that equal to x squared minus 12x plus 36? Because inner gives me negative 12x, negative 6x. Outer gives me negative 6x. We make grand total of negative 12x. Okay? Bring that over. Add 25. I get x squared minus 12x plus 61 is equal to 0. Okay, however, I'm not done, because up here I still have the x is equal to negative 1, so I bring that over, so that's x plus 1 is equal to 0. Now do I have 2 of them equal to 0? So what can I do? Attach them by multiplication, and do what? Distribute or FOIL in this case. X cubed minus 12x squared plus 61x plus x squared minus 12x plus 61. Combining like terms, I get x cubed, that's done, negative 12x, and 1x gives me negative 11x squared. 61x minus 12x gives me 61 minus 10 gives me 51. Take away 2 more gives you 49x plus 61. Oh, I forgot my square. Thank you. Just totally forgot my square there. Now, I do want to draw your attention to number 6 on tonight's worksheet. It's 0, 0, 4, and then 1 plus I square root of 2. What degree polynomial does this have to be? Sorry? How many roots do you have up there? It has to be 5, because here's 1, 2, 3, 4, and then I'm automatically I have to have 1 minus I square root of 2. Do we see that? Yes or no? So I'm going to have x equals 0, x equals 0, x equals 4, x equals 1 plus I square root of 2, and x equals 1 minus I square root of 2. That is just so that we're fully aware of that. Agree? Now, what do these two marry off to be? X squared is equal to 0, right? Because x times x is x squared, right? This turns out to be x minus 4 is equal to 0. This turns out to be x minus 1 is equal to I square root of 2. This turns out to be x minus 1 is equal to negative I square root of 2. What do those two turn out to be? X minus 1 is equal to plus or minus I square root of 2. Which then, how do I get rid of that? Square both sides, that's going to give me x minus 1 times x minus 1 is equal to I squared times, what is the square root of 2 times the square root of 2? It's just going to be 2 because that gives you the square root of 4. The square root of 4 is just going to be 2. So that's x squared minus 2x plus 1 is equal to negative 2. And I'm going to let you guys finish it from there. I've done a lot of the hard work for you, haven't I? Have I done a lot of the hard work for you? Can you guys finish it from there? Well, you can. That's your guess. Yep.
And you just take you add 2 to both sides, right?
Add 2 to both sides. And then once they're all equal to 0, I mean, you don't get how you combine. Add 2 to both
I
sides.
understand that part after you add the.
X squared minus 2x plus 3 is equal to 0. So now I'm going to marry all these by saying x squared times x minus 4 times x squared minus 2x plus 3. Yes. No. Because the square root of 2 times the square root of 2 is the square root of 4. What is the square root of 4? 2. There's no 4. I squared is -1. But what you're getting confused on is if I have I squared of 2 times I squared of 2, that's going to be I squared times the square root of 4, which is -1 times 2, which is -2. Are you with me, Alex? Now, distribute this into that, and then get that, and then FOIL again. Okay? Now, stop. We're not going to finish that. Finish that later. Okay. Now, the back side of this, you have 1, 2, 3, 4 problems on the back side of this worksheet. And the directions say use the given 0 to find all the zeros of the function. Now, I'm telling you this is my polynomial, and then I'm telling you that 5 plus 2i is going to be my root. I'm telling you that 5 plus 2i is my root. So what's my other root? Has to be 5 minus 2i, which means I have now found 2 roots, haven't I? Now, because it's the imaginary axis, if I graph that, do I know 100% that's 0? No, because the graphing calculator did not do that. So what you have to do is prove to me that that thing is a 0 by doing what? But how do you prove to me that that thing is a factor or a 0? Synthetic division, because if you do synthetic division at 5 plus 2i, what should the remainder be? 0. So what you're going to do here is you're going to do 5 plus 2i, and you're going to have 1, -7, -1, and 87. Now notice there's a lot of space in between there. Why did I leave a lot of space? Why, Steph? Because I'm multiplying by an imaginary number, which means I have a real part and an imaginary part, so you understand that. So you have to make room for that imaginary part. So what we're going to do here is we're going to drop down the 1. 1 times 5, this gives me 5. 1 times 2i gives me 2i. So what am I going to do? Add the real parts together. So what's -7 plus 5? -2 plus 2i. Now, do I expect you guys to do this all by hand and show me all the work? No. What I expect you to do is I expect you to come over here to your graphing calculator. And I expect you guys to get a new document. And you want a calculator page, and I want you to simply type in there 5 plus 2, where's I? And then in the side of the pi, put a parenthesis around it, you're going to multiply that by -2 plus 2i. And hit enter. And it's going to do the math for you to give you -14 plus 6i. So I come over here, I'm going to put in here -14 plus 6i. That is going to give me -15 plus 6i. You see that? Now, so my calculator matches up. I'm going to simply subtract 1 off there to get the -15 plus 6i. Then I'm going to multiply that. See how I got the multiplication key? It gave me answer. Parenthesis 5 plus 2i again. So I don't have to think about it. The calculator does the whole thing for me. And what's it give me? -87, which that has proven to give me a 0, which means that is what? A factor, meaning it is a 0. So now I have to prove what else to be a 0. The other one, which the other one is going to be 5 minus 2i. So from here, I'm going to drop down my 1. 1 times 5 is 5. 1 times -2 is -2i. My i's cancel, and I'm left with a 3. Well, what's 3 times 5? 15. What's 3 times 2i? Minus 6i. What happens to both of those? They cancel out, right? Now you tell me, what degrees are these? Well, when I did synthetic division the first time, I was degree 2 because I was a 3, so I did it one time, it gave me degree 2. Now I did synthetic division again, it drops it down to degree 1. Now what's my final root algebraically? Well, this polynomial is going to be what? X minus 3 or plus 3 is equal to 0. So can I find my last root? What is it? X equals negative 3. So that's going to be my last root. Now, could I have found that graphically right away? Yeah, because all I have to do is actually come over here and graph this thing. So if I insert a new page and I graph this thing, it's x cubed minus 7x squared minus x plus 87. No one was going to tell me that I was up there. Thanks, guys. Way to have my back. And hit enter. Do you see? You can tell right there it goes, shoots right down through negative 3. But why did I make you do synthetic division? The algebraic would prove that they are roots. Okay? Now, what if I were to give you a polynomial of degree 4, and they were all imaginary roots? Could you find out how to do that now? I have to give you one of the imaginary roots, though, don't I? Because if I give you one of the imaginary roots, you automatically have 2, correct? And then you get it down to synthetic division, and you get it down to degree 2, and then what? How can you find the other 2 imaginary roots? X equals negative b plus the minus squared, b to the minus 4, all over 2a. Right? Okay. Here's your homework for tonight. I would put it to the first parenthesis only, and then after you put it in the first parenthesis, then you'll go into the second one. Because it's already. Okay, the rest of the period is yours to work on this worksheet. You guys have no idea how much I totally rearranged my teaching so that I gave you time to do homework in class. You're welcome. Okay?